Welcome to Six Sigma Online Certifications. We are on the topic Control Tools and Documentation Control Plan. In this video, we will discuss about Control Plan. As per ASQ, the definition of Control Plan is written description of systems for controlling part and process quality by addressing the key characteristics and engineering requirements. AIAG AP manual adds to the definition the need of control plans at different phases of product development, which is prototype control plan, pre-launch control plan, and production control plan. It should also be noted that control plan is a dynamic tool and needs to be updated for any relevant changes done on the floor. We will understand control plan by its 10-point definition one by one. First, let us understand point number 1 to 3 of the definition. The point number 1 is process step. We should mention the specific process step for which we are trying to define the control plan. It is wise to link it to the process flow diagrams which we understood in the previous videos. The second point is characteristic to control needs to be defined. We should clearly define it as product characteristic or process characteristics, and then give the specific definition to the characteristic that we are controlling. And the third is specification or the requirement of the characteristics, which is defined by the designer or the customer. Let us take an example to understand it better. So our process step is UV heating in ovens. Now this point number 2 is we define it as process or product characteristic. Process means input characteristic, product means output characteristic. Then we define what characteristic, it is oven temperature, and then unit of measurement is degree centigrade. Then step number 3 is specification or requirement. In this case, the temperature needs to be less than 35 degrees centigrade. We go to point number 4 to 9. Point number 4 specifies measurement method. How do we plan to measure the characteristics? So exactly how we are going to measure the characteristic. Then who measures and where recorded. Whatever we measure in point number 4, we need who is going to measure and where we are going to record the readings. Then we have to define what is the sample size. That means how many samples or pieces we are going to measure at a time. And then what is the frequency, at hourly, minute, or every consignment or every lot, how we are going to collect the sample. And then defining control method. That means what is the method of controlling if the characteristic has to be maintained in the given operating range. Let us take an example. Point number 4, 5, 6, which means measurement method, who measures, where recorded, is mentioned in this section, where we, in the example, we are saying the measurement is automatic, not manual. Then we mention what is the instrument, which instrument is being used, which is RTD, which is fitted at air inlet, gives us the temperature. And we have mentioned the instrument number as specific instrument number, which we are referring here. SOP in case of manual is mandatory, but in case of automatic it is optional. Then how do we record it? It is a display of temperature as well as 7 days history is available in the system. So this defines point number 4, 5, 6. Point number 7 is sample size. So the reading is being taken every every 2 seconds, and therefore 30 readings are being averaged, and therefore our sample size is 30 and our sample frequency is 1 minute. What is the control method? Control method is that RTD gives feedback to oil flow control valve, which adjusts the oil flow and hence temperature of the air. It is an automatic control system, therefore it is in control type is error proof. We can also link this control plan to the specific gauge plan. We can identify all the instruments being used in various steps of control and then put them together for making a gauge plan for effective calibration and GRR studies. Final step, which is step number 10 or point number 10, where we are talking about decision rule. It is what to do if things go out of control or the control fails itself. For example, if the temperature is beyond the acceptable range, we have to manually stop the UV heater reject the products inside the heater, and inform maintenance for correction. We can also mention the work instruction to be used at various for deploying the control method. Thank you very much for testing your knowledge on this video, or for Six Sigma certification, visit leandigit.com. For more information on this topic, please subscribe our channel.